to expand your mind. At the end of the video on the Doppler effect, we found out that objects that emit light, we'll just say stars, that are moving towards you have their light shifted to a higher frequency. Right? The waves reach you more times per second. So we call that blue shifting. The light's shifted to the blue end of the spectrum. If the star's moving away from you, then the light is shifted to a lower frequency, and we call that red shifting, shifted to the red end of the spectrum. And it turns out that almost all of the matter in the universe is moving away from us, is red shifted, which leads to one very sensible conclusion. We are at the centre of the universe. Yes! Go us. Well, Edwin Hubble in 1929 decided to investigate this a little bit more thoroughly, and he did something very clever. He wanted to find out how the distance from various galaxies from Earth compared with how fast they were moving away from us. And here's a wee example of what he did. So, the bottom spectrum here, this is of the Sun, it's just for comparison, and the top spectrum at the moment is of a nearby galaxy. And you can see that the spectrum is shifted slightly to the red end of the spectrum relative to the Sun. So that galaxy is moving away from us, but not very quickly. Now watch what happens when I look at a distant galaxy. Okay, now you can see the light is very strongly red shifted. In other words, this galaxy is moving away from us very rapidly. Edwin Hubble did this with about 24 galaxies in total, and he plotted a graph that looks like this. So there's the distance on the x-axis, how far away the galaxy is, and how fast it's moving away from us on the y-axis. And there is a clear relationship. The further you go from us, the faster you're moving away. Now, if we're at the centre of the universe, that makes no sense. Because there shouldn't be any reason why things that are further away are moving away any faster. There'll be some variation, but overall you'd expect to see pretty much a horizontal line. So we need another theory, and that theory is that the universe itself is expanding. Space is getting bigger. Now, to see how that theory ties in with this graph, I've made my very own universe, which is pretty exciting. So, the beings in this universe would all study physics. They'd all support Celtic Football Club, being the greatest club in history, and they eat fruit and fibre every morning of their lives. So, pretty much the perfect existence. So let's see what happens with this universe. I'll introduce it to you first. The green galaxy, that's the Milky Way. That's where we are observing from. This is the blue galaxy, the nearby one. It's called Blueborough. And the distant galaxy, the red one, is called Redville. At the moment, each of these galaxies are 1 million light years apart. I know it doesn't look like it, but just trust me. So that means that Blueborough is 1 million light years from the Milky Way, us, and Redville is 2 million light years away from us. Now I'm going to double the size of my universe and see what happens. So Blueborough starts 1 million light years away. If I double the size of the universe, it's now 2 million light years away. It's gone from 1 to 2 million light years. It's gained 1 million light years. Now let's look at Redville. Redville starts 2 million light years away. If I double the size of the universe, it doesn't take a genius to realise that then it will be 4 million light years away. It's gone from 2 million to 4 million light years away. So it's gained 2 million light years. It's gained 2 million light years in the same amount of time it took Blueborough to gain 1. The only way it could have done that was that it must be appearing to move away faster, more quickly. In other words, be more redshifted. Which would completely explain this graph. Things that are further away are also moving away more quickly. Even if you didn't get any of that, just watch me rapidly expand the universe, and you will see the red galaxy move faster. Okay. Now that doesn't necessarily explain why it is that everything seems to be moving away from us. Are we not special? So if this is the Milky Way galaxy, and I expand the universe, all the other red dots, all the other galaxies seem to move away from us. But I could do that with any red dot. I could go to this one over here. And that person there would see exactly the same thing. Everything is moving away from everything else because space itself is expanding. Now that begs an interesting question. What happens if you rewind the clock? Where does all the matter go? Well, to answer that question, I'm going to have to produce another video. So tune into that one, and I'll give you some background information about the Big Bang. That was a hilarious pun, by the way, so you should be laughing.